Hello guys, welcome to my new video. In previous video we have discussed about laws of motion. From this video we'll be discussing about work, energy and power. So let's get started. Now let's discuss about work first. Let's take a real life example where a man is pushing a big rock. In real life we say that this man is pushing some rock. That is the reason why he is doing some work. Whether it is correct according to physics, let's discuss. According to physics, work is nothing but, let's say when a force applied on an object and then that object is displaced in the direction of that force. At that time, work is said to be done. So formula for the work done is given as W is equals to F into S, where F is force and S is displacement. And the SI unit of work is Newton meter or joule, where Newton is the unit of force and meter is the unit of displacement. So before going to the next concept, just go through scalar and vector product. And if you need separate video on that, just comment below. Now let's discuss about work energy theorem. Let's consider second equation of motion, that is v square minus u square is equals to 2as, where v is final velocity, u is initial velocity, a is acceleration and s is displacement. Let's consider this as equation number 1. Now let's multiply m by 2 on both of the sides. So after multiplying that, we will get mv square divided by 2 minus mu square divided by 2, that is equals to m into a into s. And according to Newton's second law, we know that F is equals to ma. So just substitute F in place of ma, we will get mas is equals to fs. And since we know that from the definition of work done is nothing but force into displacement, we can write fs is equals to w. And since in the first term we have final velocity and in the second term we have initial velocity, we can call first term as final kinetic energy. And similarly, second term is known as initial kinetic energy. Just substitute kf and ki in place of first and second term, we will get kf minus ki is equals to w, where kf is final kinetic energy and ki is initial kinetic energy. So from this we can write the change in kinetic energy of a particle is equal to the work done on it by the net force. So this is about work energy theory. Now let's explore more about work. We know that work is related to force and the displacement. Let's consider a box which is kept on a floor. And let's apply some force F, which is at an angle theta with a horizontal. So after applying this force, that box is displaced in the direction of force. That is, displacement is taken as d. And since force is acting at an angle, it is divided into horizontal component and a vertical component. The horizontal component is known as F cos theta and vertical component is known as F sin theta. And since we know that from the definition of work done, the displacement is in the direction of force. So here F cos theta is in the direction of displacement. So let's take F cos theta in place of F. So we get W is equals to F cos theta into t. Just rearranging this, we will get W is equals to Ft cos theta.
And from the scalar and vector product,
we will get W is equals to F dot t, that is a dot product between the two components. There is an important question, that is when the work done is 0. So let's discuss about conditions when the work done is 0. Consider the formula, that is W is equals to Ft cos theta. So based on this formula, we have three conditions. So the first condition is if the displacement is 0, that is d will become 0 and then W will become 0. That is work done is equals to 0 when the displacement is 0. Second condition is if the force is equals to 0. That is, if you substitute f is equals to 0 in the above equation, we will get w is equals to 0 into d cos theta. So that will be equals to 0. So this is the second condition. And the third condition is if the force and displacement are perpendicular to each other. If the force and displacement are perpendicular to each other, the angle between them will be 90 degree. So if we substitute 90 degree in the above formula, we will get W is equals to FD cos 90 degree. And we know that cos 90 degree is equals to 0. So because of that, work done will become 0. So these are the three conditions when the work done is 0. There is another important question, that is when the work done is positive and when it is negative. So let's consider the same formula, that is W is equals to FD cos theta. If the angle is between 0 to 90 degree, then cos theta will be positive. Because of that, W will be positive. And if the angle is between 90 to 180 degree, then the cos theta will become negative. So because of that, work done, that is W, will become negative.